Have you ever considered this question? Venus is often called Earth's sister planet. Compared to Mars, it looks much more like Earth and is physically closer to us. Yet, why does humanity dream of immigrating to Mars rather than Venus? Venus is the second closest planet to the Sun. When it reaches its perigee, which is the point in orbit closest to Earth, it is the nearest planet to us, with a minimum distance of only about 25 million miles. If you count the orbits from the inside out, Venus is the second child of the solar system, while Earth is the third. Why is Venus called Earth's sister? Simply put, they are incredibly alike. The diameter of Venus is only about 400 miles shorter than Earth's. It measures roughly 7,520 miles, which is 95% of Earth's size. Since the diameter is slightly smaller, the overall stature is just a bit petite. Venus has about 86% of Earth's volume and 82% of its mass. Similar volume, similar mass, and their density and composition are not too different either. Furthermore, gravity on Venus is roughly 90% of Earth's. If you were to jump off the top of the Burj Khalifa in Dubai, you would hit the ground in about 84.5 seconds. On Venus, that time would stretch to 93 seconds. This gives you an extra 10 seconds to reflect on your life choices. From space, Venus looks like Earth in a size small. If Earth is the fit and athletic younger sister, Venus is the slightly shorter, leaner, older sister. Change the skin color of Venus a bit and they would look like identical twins. If Earth is the mother of humanity, then Venus, our auntie, is incredibly flashy. There is a reason she is named after the Roman goddess of love and beauty. Venus is the only planet in the solar system named after a female goddess. Her brightness makes her the brightest object you can see with the naked eye, aside from the sun and moon. Under good weather conditions and with no light pollution, you can actually see your own faint shadow cast by the light of Venus. It makes you wonder if the ancient poets who wrote about dancing with their shadows under the moon were actually seeing their shadows under Venus. Since they are like twin sisters and live so close, popping over to Auntie's house for a visit sounds like a nice idea, right? It takes only about 100 days for a spacecraft to traverse the void and reach Venus. The first thing you see is the thick atmosphere. Compared to Earth, Venus seems much more shy. From space, you cannot see the surface at all with the naked eye. If the atmosphere of Earth is a white, sheer veil, then Venus looks like it is wrapped in layers of water-soaked brown parchment, dense and shifting in color. The composition of the atmosphere on Venus is not just different from Earth, it is a completely different beast. Carbon dioxide makes up over 96% of it, with about 3% nitrogen and trace amounts of other gases. To land on the surface, you first have to pass through a sea of carbon dioxide in the upper atmosphere. The pressure is immense. Near the surface, the gas density is so high that, under the extreme heat and pressure, some of the carbon dioxide exists as a supercritical fluid. This heavy, dense atmosphere blankets the entire planet with a thickness exceeding 120 miles. At an altitude of about 43 miles, you pass through a 15-mile thick layer of opaque yellow clouds. On Earth, clouds are made of water vapor. Here, they are made of sulfuric acid. Not only is this zone filled with highly corrosive acid droplets, but the wind speeds are terrifying. On Earth, a violent Category 5 hurricane blows at about 157 miles per hour. Here, you would face superstorms clocking in at 220 miles per hour. If you survive the acid bath, withstand the erosion of the storms, and pass through these hellish trials, congratulations. You have successfully unveiled the mystery and can finally see the surface of Venus. So, what is life like on the surface? First, you need a very special spacesuit. Current suits are designed for the cold vacuum of space, which is useless here. Everyone knows carbon dioxide is heavy, like dry ice fog sinking to the floor on a stage. The atmosphere on Venus is much denser than on Earth. This results in a surface pressure 92 times that of Earth. This is equivalent to the crushing pressure found 3,000 feet deep in the ocean. Without protection, the atmospheric pressure would instantly crush a human body. Beyond the pressure, you must withstand the heat. The surface temperature is around 860 degrees Fahrenheit. This is significantly hotter than Mercury, even though Mercury is closer to the Sunday. The culprit, again, is carbon dioxide. As the most notorious greenhouse gas, the thick layer of carbon dioxide reflects 70% of solar radiation, but it traps the remaining heat completely, acting like a thick thermal quilt, locking the heat against the surface. If there were ever plants or animals like those on Earth, they would be carbonized and crushed in this extreme environment. Liquid water is impossible, and do not hope to find a cool spot. The runaway greenhouse effect means the heat is uniform. Day or night, North Pole or South Pole, everywhere is a furnace. Once you solve the heat and pressure issues, you can finally take your first step. What does the scenery look like? It can be summarized in 3 words: yellow, red, and violent. The surface is a world dominated by volcanoes and lava, dark and monotonous. The sun-blocking sulfuric clouds keep the world in a perpetual twilight. Above is a yellow sky. Below is reddish-brown rocky land. It is vast but not flat. The ground is scattered with blocky rocks of various sizes, and the silicate surface gives off an eerie glow in the dim light. Winding gullies and folds cover the ground, some stretching for hundreds of miles. Although the storms high above are violent, the surface winds are slow, only a few miles per hour. The weathered rock dust is not blown around much. If you step there, you would leave a clear footprint. Compared to the moon, there are fewer craters, only about 900 known ones, but they are all large. Small meteors burn up completely in the thick atmosphere, so only the big ones make it to the ground to leave a mark. According to incomplete statistics, there are over 1,600 large volcanoes and millions of small ones. Hundreds of these have diameters exceeding 60 miles. It is speculated that volcanic activity is more frequent than we imagine, and many may still be active today. Let's talk about time. A year on Venus, meaning its orbital period is only about 225 Earth days. But its day, meaning its rotation period, is 243 Earth days. This situation, where a day is longer than a year, is unique among the solar system's planets. Furthermore, the axial tilt of Venus is 177 degrees. Compared to Uranus, which rotates lying down, Venus is essentially upside down, spinning like a top, standing on its head while circling the sun in a nearly perfect circle. This unique movement means a single solar day on Venus lasts 117 Earth days. The sun rises in the west, and you have to wait 58 days to see it set in the east. That is right, a western sunrise and an eastern sunset. Then comes a 58-day-long night. With such a long cycle, a single day's diary entry would be a novel. You close your eyes, open them, and the day has passed. Close them again, open them, and a year has passed. It is no exaggeration to say that here, a day truly feels like a year. That is, assuming you can stay awake for the daylight phase. Therefore, wanting to build a base and live on Venus long term is essentially like walking up to the devil himself and asking to open up a new level of hell for a dormitory. Even the devil would probably toast you out of respect for your audacity. According to the global map mapped by the US Magellan probe in 1992, the terrain of Venus is quite diverse. There are plains and basins, highlands and mountains. Volcanoes, big and small, are scattered everywhere, and lava channels crisscross the land. It is a vast yet desolate world. The landscape is monotonous but hardly peaceful. The sounds you might hear would be volcanic eruptions or perhaps thunder. This is the real Venus. No water, no oxygen, frequent lightning, restless volcanoes, accompanied by extreme heat and crushing pressure. The long days are shrouded in a heavy, depressing yellow gloom. At night, the atmosphere completely blocks starlight, but it is not pitch black. The ion movement in the upper atmosphere creates eerie, terrifying red patches that emit a faint glow. So, is there absolutely no chance of survival? Not necessarily absolute. At an altitude of about 30 miles above the surface, the atmospheric pressure, temperature, and solar radiation are similar to the surface of Earth. If we could solve the problems of floating at high altitudes, stabilizing against strong winds, and creating materials that resist sulfuric acid corrosion, a short-term station is possible. But for long-term habitation, we face a harsher problem, which is water. Venus lacks a strong magnetic field like Earth. It only has an induced magnetosphere created by the interaction of solar wind and the atmosphere. This cannot stop hydrogen and oxygen atoms from being stripped away by the solar wind. So, extracting water from hydrogen and oxygen on Venus is incredibly difficult. If Earth is a gentle, strict parent who occasionally loses her temper and spanks the kids, then Venus is a terrifying, violent tyrant. She might look like a demure beauty from afar, but get too close, and she will, without a word, crumple you into a ball and toss you into a high-pressure furnace. Your survival depends entirely on luck. In the family of the solar system, Venus has the worst temper. Contrasting this with Venus, does Earth not look particularly kind and beautiful? Birds flying high, fish swimming in the sea, it is truly a paradise for all living things. So, as a close neighbor and physically similar sister, why did Earth become the cradle of hope, while Venus fell into a nightmare hell? Venus and Earth were born together with the solar system. Starting 4.2 billion years ago, Venus went through a period of rapid cooling. As the planet evolved, silicate rocks slowly absorbed carbon dioxide from the atmosphere, locking it into the crust. In the early days of the solar system, the sun was still in its infancy regarding temperature and brightness. Its radiation was only about 70% of what it is today. Thanks to being closer to the sun, Venus was actually more habitable than Earth at that time. In 2019, a NASA research team simulated the geological changes of Venus based on Earth models. 5 different simulations all indicated that for a period of about 2 to 3 billion years, the temperature on Venus stayed between 68 and 122 degrees Fahrenheit. This is the ideal range for liquid water. At that time, Venus might have possessed oceans even vaster than Earth. In such an environment, it is highly probable that life emerged. However, about 700 million years ago, a massive catastrophe occurred. It might have been a devastating asteroid impact, or perhaps a super-scale global volcanic eruption event. We still do not know exactly what happened, but it became the turning point in the fate of Venus. This event completely altered the geological form of the planet, releasing the carbon dioxide stored in the rocks. The runaway greenhouse effect caused heat to accumulate on the surface, coinciding with the gradually increasing temperature of the Sunday. In a chain reaction, the liquid water evaporated completely. It formed a vicious cycle, and in a mere few million years, it fell from heaven into hell. I prefer to call the Venus of that ancient era the goddess. She may have been even more beautiful than today's Earth, hanging like a shining sapphire in the darkness of space. A bright atmospheric glow shimmered at her edges. Above the white clouds, she likely displayed golden or blue halos. Compared to the gray-blue tone Earth presents today, the goddess was a vivid azure, cleaner, brighter, and more enchanting. Without the thick carbon dioxide or terrifying sulfuric clouds, she had a thin atmosphere, white clouds, boundless oceans, and vast continents, just like Earth. Her landscape might have been gentler than current terrain of Earth. Being in the early stages of planetary formation, there were no towering Himalayas, no East African Rift Valley tearing the continent apart, only rolling low hills and vast plains. The ground was likely covered in fertile soil, perhaps growing primitive moss-like plants, presenting a faint green hue, fragile yet resilient. Rivers wound their way out of the hills, crossing the plains to finally merge into the ocean. The riverbeds were piled with nutrient-rich silt, perhaps already teeming with microbial life. Along the winding coastlines lay vast beaches and scattered reefs. The sky was high, the clouds pale, the sea clear, and the wind gentle. The whole world was quiet and peaceful, yet bursting with potential vitality. A new life form might have been born at any moment. Perhaps back then, Venus rotated much faster than it does now. Shorter days and nights brought a more suitable climate. Warm ocean currents and punctual monsoons would have been the norm, carrying the seeds of life to every corner of the planet. A faint buzzing of insect wings might have been the most beautiful symphony in that world, a declaration of life in the universe. There may have been storms and thunder, sending creatures burrowing into the soil to wait, but nothing could stop the desire for life to continue. When the wind stopped and the rain ceased, they would emerge to embrace the gifts of the sun once more. And when the sun set, the night sky of the goddess would become deep and distant. Without pollution, the sky was exceptionally clear. Although there was no moon, the stars shone even brighter. The Milky Way would stretch across the sky like a bright ribbon. We do not know how that night sky billions of years ago differed from Earth today, or if the stars billions of light years away shone just as brightly as they do now. However, this beauty was frozen forever at the moment of disaster. As the temperature rose and the water vapor evaporated, one wonders if the planet heard the painful groans and unwilling cries of life in its final moments. A few million years seem fleeting in the river of billions of years, yet they used the most destructive power to erase the existence of life. The goddess disappeared, leaving behind the scorching purgatory of Venus. Venus eventually underwent a global crustal restructuring, which is why its surface crust appears so young today. The overturning crust not only completely erased any traces of past life, but also intensified the release of carbon dioxide. Venus finally became what we see today. To this day, we are still exploring the true full picture of Venus, trying to understand its structure and environment, studying its evolution, and searching for evidence of past life. Although Venus exploration is not as feverish as it was in past decades, some older probes are still working and future Venus missions are already on the agenda. Humanity's path to exploring the mysteries of the universe is endless. This is not only about where we came from, but also determines where we are going. On the scale of the universe, Earth is so young. On the scale of Earth, humanity is so small. The vast universe is like a two-way mirror. One side reflects the departed goddess, and the other reflects the current Venus. When we look up at the starry sky and see that shining morning star, perhaps we should feel a sense of gratitude for Mother Earth's mercy for sparing us the same fate.